Very warm welcome to all of you on behalf of Azim Premji University. I know you attend our public lectures because you are well-wishers of Azim Premji University and you are invested in the country's education, health and development. Thank you all. We are delighted to present today's program in our series of public lectures which are held at our two campus cities here in Bangalore and Bhopal every month. Ranchi joins this list from January. Public lectures are one of the ways by which the Azim Premji Foundation promotes its vision. All our public lectures, over 125 so far, are available on our YouTube channel and I invite you to view them. A brief introduction to the speaker, the interlocutor and the topic of today. Professor Harish Chandra Verma is an Indian experimental physicist, in particular nuclear physics, author and emeritus professor at the Indian Institute of Technology, Kanpur. His book, Concepts of Physics, is famous across the country and is mandatory reading for those preparing for JEE and NEET. Interestingly, Wikipedia describes his book, Concepts of Physics, as famous for its difficulty and importance in competitive exams. He co-founded Shiksha Sopan, a social upliftment organization for economically weaker children living near the campus of IIT Kanpur. I have had a sneak peek into his presentation for today, and its simplicity tells me why, through his teaching, experiments and outreach, Professor Verma has played a pivotal role in popularizing physics across India. Many distinctions have come his way, prominently the Padma Shri and the FICCI Lifetime Achievement Award for Education. Our public lectures follow a format where we have the speaker deliver their talk and then one of my colleagues from the university engages the speaker in a short conversation. Today it will be my colleague Krupa Gauri Shankar. Krupa did her master's from IIT Madras, her PhD from the Raman Research Institute here in Bangalore, and her postdoctoral work at the University of California in Davis. She works broadly in the growing interdisciplinary area of physics and biology. Please join me in welcoming Professor H.C. Verma.
Thank you, Sudesh sir, for inviting and introducing. And thank you all faculty members, Prateek ji, Kripa ji and others and students and whatever public is here because it is public lecture series. The talk is about science, a way to connect with the nature. So that is it. And I am a science student, a physics student in fact, and now trying to learn more about nature and connect science with the nature. So during all these things, I have found that physics is so close to nature. And still it is an anomaly that people say that physics is a tough subject. Similarly for mathematics. India, who has led the whole world in the field of mathematics, and we have given the decimal system, we have given so many theorems in geometry and astronomy and trigonometry, and then our Indian young students say that mathematics is difficult. These are really, something is wrong somewhere. And the wrong is that we do not connect with the nature. Our textbooks, our syllabus, our examination system, all these things, it's not connecting with the life, it's not connecting with the nature, and that is why all these things become something alien, something imposed, something which is external to our life. So that is the basic problem. And that is how, when the concepts of physics, the idea was conceived in way back in 1980s, early 80s or mid 80s. So this was the driving force. that physics should be told to our students in a way which connects them with their surrounding. So from there, this thing was there, and it got strengthened and strengthened and strengthened. And therefore, when the offer came for this public lecture series, I chose this topic so that I can share with others. So science, a way to connect with nature, this is it. And the world is beautiful and diverse. So the words I will be using interchangeably, you derive the right meaning. Sometimes I will say society, something I will say nature, sometimes I will say world. All this is the same for me. Whatever is there with which you are interacting, the whole ecosystem. All right, so let's see how beautiful is the world. Is it beautiful? Who is the person? He's H.C. Verma. He's H.C. Verma. Such a nice scenery, and it's somewhere in Himachal Pradesh. Okay, and the time, the year is also written there. Date is there. All right, beautiful, beautiful colors, smiling faces. Right, the most important thing is smiling faces. Smiling faces means yes, we are close to the nature. All right, my statement is, you can choose not to study science. It's your choice, option. You can go for this option, not to study science, but you cannot choose to live without science. There's no option. You have to do that. You have to do that. And why? Because you live in the nature, in your surrounding, and that surrounding teaches you physics or science in general. But since I am little more competent in physics, so when I say physics, that would mean science, basically. All right. Now, in science we say, or in physics we say, you have force of gravitation, the earth attracts everything towards itself, and the nature shows you things falling. So the nature is already giving you a demonstration of the concept which you will be reading few years later. At the age of 1 year, 2 year, from that age, everyone starts seeing all the things falling towards the earth. So the demonstration is already done. And then later on, people will read it in the textbooks. Okay, this is also part of the syllabus, right? Nature shows rainbow to teach dispersion of light. Dispersion of light means the white light splitting in 7 colors. Okay, so this is in the syllabus. Which class syllabus? Maybe class 9th or 10th or 8th, whenever this refraction and all these things are introduced. But the nature has shown this dispersion from the very beginning. It doesn't care which grade you are in. Nature does not care whether you are in class 3 or class 4 or class 5 or class 7, or you have not yet admitted in the school. Nature will show, I say that this nature is a big physics laboratory. It's a big physics laboratory. And that laboratory training you are getting all the kinds of demonstrations. Okay, if you want to learn scattering, you have already seen the red sun during sunrise and sunset and the blue sky. So that is for this thing. Nature shows freezing of lakes to teach you anomalous expansion of water. You know that anomalous expansion of water is a very important part in our thermodynamics syllabus, and very very interesting also. But then yes, the nature has shown it. It's like if you think of Dal Lake in Srinagar, the temperatures go in negatives, and the ice, the whole, if you look at the lake, it's all ice, 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 ice. And you can walk on it. You can games on that. But below the ice, it is water, and in that water, all these these aquatic living beings, they very happily they can be there. This 4 degree will not become 3 degree. It will remain 4 degree. So everyone can see that in during winters. Nature shows day and light to teach you rotation of earth. The nature shows summer and winter to teach you orbiting of earth around the sun. Mhm. So why is there summer and winter? Because because earth revolves. But why should it be summer and why should it be winter? Why should it not be same everywhere? After all, circle is symmetrical. Elliptical orbit. Then axis is tilted. Right. So all those things which you will be studying, elliptical orbit doesn't have much of effect, but tilting it does have. So the demonstration is already given by the nature. That's the point. This is the kind of summer picture and the winter picture, right? Okay. So even leaking pipes. Okay, let me show you the slide. Right? If you are able to see, you have this pipe, this rubber pipe. Okay, this pipe, and through this pipe we are sending water to. We are watering this field. It's my house. This photograph, but then it is broken here, and then the water which is going in the pipe, part of it is leaking from here, and since it's going with a velocity, it's connected to a motor, and therefore it's going with a velocity. And this, look at the path. If you are able to see some white dots, you can see here, 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 and here. So before you study in class 11 motion in 2 dimensions, and then you are told that if something is projected with some speed at some angle with the vertical, then it goes in a parabolic path. So the equations will be derived and all those things will be done, but you already have the demonstrations. Okay. All right. So okay, this is about conductivity. This is about phase change, liquid to vapor. Right? You will be studying in chemistry classes the solid, liquid, gas, and then melting point and boiling point and evaporation and like that. And here is every day from day one, whether you are going in the school or we are in class 2 or class 1 or class 10. Every day you are seeing that how that liquid becomes gas even much below the boiling point. Interesting. Okay. Nature shows seesaw to teach you laws of moments. Whether you know it or you don't know it, but you know very well that if two children are going on this seesaw and one is heavier and other is thinner, the heavier will sit closer to the fulcrum and the other one will be farther from the fulcrum. Only then it will be balanced. You have already done it. You have gotten the experience. And later on in some, when they teach you rotational dynamics in class 11, then they will tell, okay, is the moments on the two sides which are balancing. All right, oscillations. Nature shows oscillations before you teach or you learn. Officially you learn about simple harmonic motion. Okay, so let us see if it oscillates. Yes, it oscillates. Right. So from the very childhood these experiences are there from the nature. So we are connected to the science is connected to the nature. When I am learning science systematically, in the school system or later college system, then I am only giving language to these phenomena. And it's very natural to connect with the nature if you are doing science, right? Because science itself is just a study of nature only. So these are the kind of thing. Those are the excellent teaching aid for rotational dynamic. Any kind of door, almirah or window or the doors, you have an axis of rotation, and then you can talk of v is equal to omega r, blah 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 things, and so on and so forth. Fire, to teach radiation. Bangalore may not be very cold in winters, but North India is, yes. So this kind of scene is very, very popular. Whether this lady knows or doesn't know, but she is experiencing. Sitting in front of fire, you feel the warmth. Nothing is touching. Okay, so this is coming through radiation. The words uh, will be given by the school system, college system, textbook syllabus, but the phenomena, the nature shows you the phenomena. That is how science is the way to connect with the nature. Okay, so science takes you closer to the nature. This is a forest. Hmm? And universe, okay, earth, the only known place in the universe to have life, right? I think there are people who are much more informed in this climates and the forests and things like that, biology. So earth is the only known place, known. Maybe somewhere the life may be there, we cannot say that it is not. We have not proved that it is not. Okay, but the humans who are so capable that sitting in a very remote small corner of a particular galaxy, Milky Way galaxy, there are billions of galaxies, one particular galaxy million which we call Milky Way, in that there are billions of stars, and then one particular star which we call sun, and then the 8 planets, and one planet is earth. So the humans sitting in this claim that the entire universe the entire universe was created 14.5 billion years ago. That's the capability of human brain. Such a vast universe, billions of galaxies, and everything originated 14.5 billion years ago is coming from the calculations, from the understanding, from the mathematics, from this laws of nature, and they are predicting it. And then they are also predicting that if it is true, then you should see this in the universe. Wherever you can go, wherever your vehicles can go, wherever you can catch the radiation here, and they catch the radiation from stars which are hundreds and thousands light years away. So we have developed such a human, this race is such capable. And if that has not been yet found a place where life is there apart from our planet, earth is really very, very special. Earth is really very, very special. Okay, this they call it blue green algae, we call it kai. हम हिंदी में उसको काई कहते हैं. एंड इट कैन बी एनीवेयर. रोड्स पे मिल जाएंगे आपको, कहीं पर भी मिल जाएंगे, वाटर मासेस के ऊपर तैरते हुए मिल जाएंगे. And if it is on the road, it becomes slippery and you are advised to go carefully on that, नहीं तो आप काई पे फिसल जाओगे. No, if I study science, and when I studied science, in fact, this is less than 2 years ago, I started reading this particular branch of science, which is called biology. Then I came to know the chi is not a insignificant thing. First, it is there for at least something like 3 or 2.5 billion years. This sky, or this is blue green algae that they say is very foreign name for me. So that sky is continuously having in their same shape and the same properties and the same thing they are doing. 3.3 billion years or 2.5 billion years they are maintaining themselves. All right. And then I came to know, okay, these are the first living species which created oxygen in our atmosphere. Before that, before this, there was no oxygen. There was a lot of carbon dioxide and other things, but there no oxygen. And then these blue-green algae, they created oxygen in our atmosphere. And it's given the technical name great, what is it? Great oxidation event. This particular period in which these शैवाल भी कहते हैं उसको हिंदी में, किसको? इसको एल्गे को. ये शैवाल है नहीं, ये एल्गे is another classification, but this particular thing is called blue green algae. So in one particular time, these developed themselves to do the photosynthesis and create a lot of oxygen in the atmosphere. So we are very grateful. If today we are there, if humans are there and we need oxygen for our own existence, it's because of these. It's because of these blue-green algae. So if you really study science, you automatically you are dedicated to the nature. So much of emotional attachment you will have. Then water, lot of water. Earth is the only place to have liquid water so far. Wherever we know up to whatever is. This is the one place where we have so much of water. And a human body cannot live without water. We do need 3-4 liters every day drinking water. Although the oceans, the seas, there's not drinking water, but this evaporates and goes to the clouds, right? And then when that clouds again condenses and rains, that becomes drinking water. So ultimately, all this water mass which is here, that is giving us water. These blue-green algae are giving us. Even now, they are producing oxygens, right? And in very significant amount. All the trees are also doing that, but these are very effective. All right. Similarly, the mountains, the snow in glaciers reflect sunlight. This is important. The snow in these glaciers, they reflect sunlight, and this is very important because you have to make a balance between heat that you receive from the sun and the radiation which goes out of the earth. During daytimes we receive lot of energy from the sun, and daytime or night time. If at one place of earth it is daytime, the other place it will be night time. So earth as a whole is receiving all the time solar energy, right? And that much of heat radiation is coming to our thing. And then this reflection of sunlight through glaciers is one component by which we are sending this radiation back. All right. And there are other things. But if we do not send the radiation back, what will happen? What will happen? Okay. So the atmosphere gives us oxygen to breathe. right? Atmosphere. So then this is all part of nature. Nitrogen gives nutrition to the plants, and the little carbon dioxide. How much is the carbon dioxide in air? 0.04% only, right? Water vapor is much more than that. Of course, nitrogen and oxygen are the main ingredient, but then this carbon dioxide, which is so tiny, 0.04% itself, plays a big role in regulating the temperature. So we have to be grateful to our nature and the whole cycle and this ecosystem. And how does this carbon dioxide keeps us warm? Huh? All right. So plants, they prepare food for us. When I knew that okay, plants, that was also an experiential learning from the nature. Even before any textbook I read, that plants prepare food. We knew that okay, the kind of wheat and rice and other grains that we are receiving pulses, they are coming through the agriculture only. So the plants are doing that. Then kinds of fruits that we eat, mangoes and guavas and all papaya and everything. So that we know from the nature that okay, it gives us. But to realize that yes, is the plants which are preparing food for us, and then we are consuming it. So although we have seen it, but someone has to tell, look, you are alive because of this. So that is how it connects with the nature. Okay, all right. Mosquitoes. Mosquitoes. When I learned about mosquitoes some 3-4 months ago, I was really very excited. It's also part of our nature only. This lady mosquito has amazing power to detect, breathe out carbon dioxide from something like 50 meters away. How much carbon dioxide we breathe out? And once it comes out, because it is mixed with other, which gas we breathe in? Which gas we breathe in? Air, right? And which gas we breathe out? Air. What is the difference? Yeah, the difference is 4% of oxygen. We breathe in 78% of nitrogen and 21% of oxygen. When we breathe out, that 78% remains intact, right? And this 21% becomes 17%. And carbon dioxide 4% extra we breathe out. A single person sitting in a room is breathing out air. Yeah, we are breathing out air. And that air has more carbon dioxide than the usual air. And 50 meters, remember, more than 150 feet. This, this female mosquito can detect that, okay, from this direction, the air which is coming from this direction has more carbon dioxide. Some human person is there. And then he starts navigating and taking that journey. Okay, once it becomes closer, then other things also start helping the mosquito. When they are closer, then the sweat, your sweat smell and other things also come into picture. But the journeys can start 50 meters away. So I was really I got attached to mosquitoes. And I stopped killing mosquitoes. No bat, that बैट बैडमिंटन वाला होता है ना उस टाइप का, आप ऐसा ऐसा करके मच्छर मारते रहते हो. Absolutely no. Good night and all these things are not that harmful, but still I feel like they may be harmful for the mosquitoes. Therefore, I don't use it. I always use this mosquito net. All right, I use odomas or those kind of things, but certainly I don't kill mosquitoes. After knowing that, okay, mosquitoes are like that. There are the intelligence. You will be really, you will start respecting the intelligent animals. After humans, after humans, people say that crow is the most intelligent. It has only 4 grams of brain. But crow is and people have done experiments. You know that the story. There was a pitcher, and some water was there, and the crow was thirsty, and the crow came. He could not reach the water level, so he put some stones in that, and then it comes up. That water level comes up, and then crows takes the water and goes away. That's the story. Now, people have done real experiments with the crows, and they have put cylinders with water, and then they have put some pebbles and of various sizes, and the stones and the plastics and the soil, those different kinds of pebbles they have put there, and then the crow comes. And everything is being recorded. All the things are recorded. The crow comes, sits on that cylindrical jar in which the water is there, and he sees that, yes, is not able to reach there. He comes down, picks up one particular one, right? And then it will drop in this water, or it will throw that away. Not every time it picks up and puts it there. When it picks up, it estimates the density of the material. If it is a plastic thing, okay, or it is a wooden thing, he will not put it in the water. He will throw it out. And only the heavier ones, the stone type of things, only that he will pick and he will put in the water. And finally, the level does come up, and this crow, on which the experiment is being done. So people are, our animals, our birds are have so much of intelligence. I have all those videos, although it's long videos, I did not put on the slide. Then I have another video. In fact, I wanted to put it here, but since it was this PPT was created yesterday night, on late night, so I did not have all the facilities of video editing and other things here. So I otherwise I could have cut, and some portions I could have shown. Something called the hunter fish. This video is really interesting. This is really very interesting. There is some big insect or something on a tree or somewhere, and this fish wants to hit that and let it fall. Now, what does fish do? It positions itself at some distance from that insect, and takes lot of water in the mouth, lot of water. Then he peeps out of the surface of the water and injects that water, this whole water, like a jet, a thick jet of water, and the water goes and straight hit on the insect, and the insect falls. Okay, and this fish, after throwing that water jet, this fish, it starts moving towards that, because it was at some distance from that vertical line. So it has to catch that. It has to catch that. So the fish knows that this will fall, and this much time it will take here. At the right speed it goes, and just as it touches the water, it grabs. Wonderful. And even more wonderful, even more wonderful is yet to come. There's a baby fish. There's a baby fish. He sees that mother fish or the adult fish is doing this kind of thing, so he also the baby has grown, but is still baby, he also locates some insect somewhere, and he also does the same. And then he grabs a lot of water in the mouth, and then he peeps out, and then throws that. Okay, and the jet goes above the insect. It doesn't hit. It doesn't hit. One trial, two trial, three trial. It doesn't hit. This baby fish swims, goes near that adult fish, and when the adult fish is doing this hunting next time, she just watches it very carefully. Nothing else, just watches. And after the watch, it comes back. And next time when it locates some insect and sends that water jet, it goes and directly hit. And the insect falls. That's the kind of intelligence. What she had learned, if you are seeing the insect from inside the water, the insect will appear to you slightly, the image will be slightly above, because light bends when it enters from air into water. It bends. What you see from that bent light that is entering the eye, so the image will be formed on that line. So the image is formed slightly above. This adult fish knows it. It doesn't aim at that image. It makes the jet at a certain lower angle, and the estimates and calculations, everything are so perfect that with the right amount, with very right amount, it will aim. This angle will be decreased, and then it will go and hit. Since the baby fish has done it 3 trials and it could not, then she watches carefully what is adult doing, because this baby fish is also there itself. So it can also see that, okay, here is the insect, but the angle is slightly lower. It can learn that. It can observe. It can observe. This is one of the most important part of the science, the experimental science. You have to observe very carefully, and then look at it, and then analyze, and then make your plannings. This adult fish is doing that, and the baby fish, by observation, understands, okay, the target is there. I can see the target is there, but the angle is slightly lower, and then learns, and then goes back, and then hits. Yes, in the first go, it hits the insect. Do you develop some respect for all these these living beings? They are just not some animals and some birds. They are really, really very, very intelligent. But what is lacking? What is the difference between humans and these intelligent animals? The difference is we can plan for the future. Humans can plan for the futures. That part, these animals, these birds, they do not do. Otherwise, they are very, very intelligent. Okay, fine. Soil gives us agriculture. Perfect distance from the sun to have a moderate temperature here. Perfect difference. If it is slightly that side, slightly this side, the life would not have been possible. But it's not only the distance. It's not only the distance, because whatever at this distance, whatever solar energy we are receiving all the time from the sun is huge. Is huge. Moon and the earth, as far as sun goes, they are at the same distance, right? Because moon's distance from earth is hardly some 3.5 lakh kilometers or so. This light takes some 1.3 seconds. Light takes something like 1.3 seconds to reach moon. And to reach sun, it takes 500 seconds. 500 seconds. So for that particular distance, Earth and Moon are almost at the same distance. But look at the temperatures of the Moon, right? Look at the temperature of the Moon. Now, all of you know that the Earth has a magnetic field. Earth is a magnet. Now, Earth is a magnet. It has its own magnetic field. It's not just that, okay, Earth is a magnet and it has a magnetic field. Lot of high speed cosmic ray particles which are coming from the sun and other objects, say in space, lot of them are coming towards, they are going in all directions, not that they are aiming to hit the Earth, they are going on all directions, so they are also heading towards Earth also. If those many high speed particles hit every second our Earth, it will be very, very difficult to have any life or anything. But this magnetic field that the Earth has, this magnetic field deviates them. This is the Earth here, this is the Earth here, and this is the magnetic field here. And these are the kind of those high energy particles, and this magnetic field deflects them. Deflects them. They are initially they are heading towards the Earth, but this magnetic field deviates all those things. This goes here, and so on, and we are saved. So, magnet we have seen, we have played with the magnet. But if we learn science, it tells me that, okay, it's much more than that. It's much more than that. Earth is a magnetic, Earth is a magnet. It's much more than that. The Earth is saving us from all these high energy cosmic particles by deflecting the things. And that is why we are here. The whole nature, you have to be really, you should admire and be grateful. Okay. Okay. Yes, it is there. So that's the kind of relation we have. Enjoying the nature. First, you enjoy the nature. From the very childhood, you enjoy everything. All those demonstrations that I said. It's a great physics laboratory. It's a great physics laboratory. So it's there. And then you start respect. As you study science, you start respecting, and then you are being with the nature, and finally understanding the nature and assuming that you are part of it. Okay. But nature is in a very, very delicate balance. Very, very delicate balance. And the most intelligent species, which is human, they are the biggest danger to the nature. All right, they're the biggest. These fishes and crows and mosquitoes are not at all danger to the nature, but this human is the biggest danger to the nature. If you don't study science in a proper manner, then you don't respect nature. And if you don't respect nature, then for immediate gains, you can really destroy the nature. That's what is happening. This is moon. This is moon. And this cartoon puts a thermometer here and asks how much is the temperature. And it is plus 120 degrees Celsius during day on moon, and minus 130 degrees Celsius in night at the moon. Is that it's at the same distance from the sun. The moon and earth are at the same distance on the sun. Okay, so temperature variation is from plus 120 to minus 130 between day and night. For us, the temperature variation is hardly 5-10 degrees. And why it is there? Because the very delicate balance where we are receiving the radiation and we are also emitting. We are also emitting. Okay, we are also emitting. And then our atmosphere has some kind of carbon dioxide or greenhouse gases which allows a particular amount to retain so that it doesn't drop to minus 120 degree in the night. And then it also restrict the radiation for coming, so it cannot be plus 120 degree also. So this is the kind of atmosphere that is doing. Okay, so we are sending lot of carbon dioxide in atmosphere, this humans. We are sending lot of carbon dioxide, and that carbon dioxide will increase the trapping of the radiation. All right, and if it increases the trapping, the temperature of Earth is going up. And in the last 10 years, I was just looking at the data yesterday. The last 10 years, or the data was up to some 2020. So the last 10 years increase in temperature was much more than 50 years increase. Previous 50 years increase in temperature, and the last 10 years, the last 10 years data is something like double of that. So by sending this CO2 in atmosphere, we are tampering with that delicate balance it has, so that we do have a comfortable temperature day and night and so on. Now this carbon dioxide comes from many sources. One is petrol, diesel, CNG. I'm not talking of pollution. Pollution is not a danger to the nature. Pollution is danger to the human. Okay, if there are smoke particles, carbon particles, nature doesn't care. But if carbon dioxide is going in atmosphere, yes, yes, it is danger to the this one. Then electricity. Our in our nation, some 80-85%, 90% of that order, electricity is generated from the thermal power plants. Okay, it's the thermal power plants, and there the coal is burnt. Right, so much of electricity is produced in thermal power plants across the nation, and so much coal is being burnt, and that is putting carbon dioxide into our atmosphere. All right, so this is another big story. Then, then whenever we are using electricity, whether this is sound system, video system, the lights here, the lift, whenever there we are using electricity, we are becoming part of that global warming, because for that electricity coal was burned and carbon dioxide was put in the atmosphere. Okay, so and electricity, all factories, like LPG, every day, for lunch, for dinner, for breakfast, some 5-6 hours our LPG is on, and LPG is a hydrocarbon, and it burns and it produces carbon dioxide. So that is also sending carbon dioxide in atmosphere. All right, and then breathing out. Everyone, including species other than humans, including plants also, they breathe out and they put carbon dioxide there. But the balance is such that if humans are breathing in and breathing out, and trees are there, forests are there, then it becomes a cycle, and there's no overload of carbon dioxide. But this burning petrol, burning coal for electricity production, that is an addition to this carbon dioxide. So we have to look at the essential carbon dioxide emission by us and non-essential. LPG, yes, okay, it is essential. Breathing out it is essential. That's fine. And our earth is ready for that. Our earth has no problem with that. All the human beings, all those living beings on the earth, they can breathe out carbon dioxide, provided the forests are there, the trees are there, all those blue, green algae are there, fine. But out of proportion production of carbon dioxide, that is giving a very, very alarming situation. This lower figure you can see, this is a, see what is the situation, what is this? Yeah, it is lift. Huh? And I believe this is some kind of young girl who is pressing that number 1. She has to go from 0 to 1. But the electricity will be used. The electricity will be used. Okay? In every action, we should pause and think, is it essential carbon dioxide I am putting, or it is non-essential one? And we should refrain. It's okay, our small contribution of not using lift and using stairs may not change the scenario. But we have to keep this awareness in the society. If we do it and we make people aware of it, that yes, the beautiful nature is in danger, then yes. So that is it. Okay. All right. So any item that you purchase from the shop was designed in some factory, most of it, apart from your agricultural product. Design in the factory, there will be machines, there will be electricity, then it will be transported from that factory to your city, then from your city center to the shops, different shops. So the transportation, petrol and diesel will be sending carbon dioxide. Anything you purchase, you should have this balance sheet. How much carbon dioxide was put in preparing and transporting and delivering to us, right? So one has to be very, very conscious on that. All right. So be part of the nature or be consumer of the nature. Now, if the humans are very, very intelligent and capacious species, and if they want, they can ruin the nature. They have this capacity. All right. So if I am part of the nature, I am also nature. I am also nature. What is nature? Nature is everything, all the world. So I am also part of it. I am also nature. Then I will not harm it. But if I don't have that connection, and that connection can come from science. If I study the biology, I see the climate science. If I study all the environmental science, I see geology, botany, physics, chemistry, earth science, right? Atmospheric science. Then yes, then this will come, and it is. So this is my final slide, and the message is life must be useful. Okay, thank you.
So thanks, Professor, for that very nice talk. What I really liked was the simple way in which you explained a lot of things and how passionate you were about everything you explained. And you have seemed to have this childlike enthusiasm for, everything from drying clothes to hunter fish.
Thank you. Thank you.
So I just had a few questions which I've written down on my phone. I hope you don't mind my reading it. Yeah. So in the early part of your talk, you talked a lot about how science is already there and it is nature is showing us. And basically, I guess it was about observation. But I wanted to ask, um, you know, when we are growing up, of course, we observe things, but often we miss things. And sometimes we need somebody to point it out to us, right? So, what are your thoughts on that? Do students just naturally, do you think they have this capacity to observe and also process and synthesize?
No, my stand is that all our students before coming to school system, they have learned lot of physics, chemistry, biology, and psychology and everything. If someone knocks on the door and the 4-year old child or 3-year old child opens the door, by looking at the height, the face, the child can decide, should I call him Baba or Bhaiya or Behen or Auntie or Uncle. No, this learning is there. A child of 3-4 years can do it, and he does it. This is not a small thing. Looking at the face and the body structure, if you can estimate, then this should be the age and this should be the relation, and I should call it by this and that. So, from the nature, from the observation, the child has learned many things for which there are no written statements, no technical terms, and no laws as such. Yes. Right? But the essence is very much there. So, in the school system, we should cash on it, which we are not doing. Which we are not. We are saying, in the 9th class only, we will tell that the body at rest will remain at rest. All right. So, we are not utilizing the fact that the child knows it. Now you give the words, now you give the mathematics, now you give the what extension can be made using this. So that is the kind of gap which is there.
So again, on the same topic of observation, as you said, we don't have words sometimes to explain those things that we have observed. We have some intuitive understanding of it. And I mean, doing science is, of course, there is a lot of observation, but on top of that, there's a lot of things. And as you said in the beginning, maybe not in the talk, but upstairs in the interview, you said, oh, students think physics is very tough. But there is a little truth to it, right? Physics is a bit tough. So,
Is life not tough? See, in the human life, there will be challenges, there will be difficulties. So, what should I learn? To avoid the challenges, to avoid the difficulties, or to face it. Okay. So, if it is bit tough, it's fine. It's fine, no problem of that. If it is tough and you struggle to understand it, you enrich your thinking power. Right? If things are all simple things come up, then you don't have to struggle, you don't have to think. Your thinking powers, your innovation power, all these things will not develop. So bit tough is already good. But then what we are doing in our system is we are delinking that. We are delinking this. It's tough because it appears as if it is imposed on us. It's not imposed. All the things that we do, at least in physics, I know, and of course in biology and chemistry and earth science and everywhere, what we are doing is that we assume that, okay, the child does not know ABC of it, and we define. So once it comes as a definition, as a law, as some equation, as some formula, without linking it with our prior experiences, that is why it appears tough.
yeah, that's true. Um, so I'm asking from a selfish point of view because I see this problem in several of our students that once they come to university and start learning physics the way it is at the standard that they're expected to know physics, they get a little, well, they're a little too overwhelmed, I would say, right? But at the same time, they have this childlike wonder of nature and all of that. So how do we keep them motivated while at the same time preserving that sense of wonder?
I think we are not giving the right kind of examples. I talked about this archer fish. I talked about the crow actually putting a stone in water. These things are available. People have done researches, and these things are available, commonly available. Okay, you don't have to get a license to use them. All right, these kind of things we are not putting there. 60 years ago, what I had learned in my science book, same examples and same things are put even now in our new textbooks.
Right.
Okay. So if the thinkers, policy makers, or educational syllabus makers, or educational content developers, if they can do some research on it, whatever level, this level was archer fish level was not some BS bachelors or masters. Whatever level, if there are such interesting things available, bring it, bring it. Yeah.
Yeah, exactly. Because also you have written these textbooks, right, which are legendary. And most of the textbooks that I have seen in physics, they have really old-fashioned example. Most of the time to do with military or
Yes.
somebody shooting somebody else. And yeah, these kinds of examples would probably bring them closer to nature. I now wanted to sort of ask a question from, like, I guess the point of view of the audience who are regular people from Bangalore who have come to see you talk. Um, like, how do they start doing this and incorporating, observation and getting closer to nature using science through just observation? Because, of course, there's a huge gap. There is not a huge gap, but there is a gap between observing and deeper
Analyzing.
understanding. Yeah. So how do people engage? regular people?
I don't know. I don't know. You were talking of science students, I think.
No, just citizens, like people.
Citizens. Oh, that's very simple then. That's very simple. Just do some reading. Do some reading. Scientific American publishes newsletter every day. And I have subscribed that. So every day I will come to know some exciting things. Not every day. I will not understand anything on a particular day of the 5, 6 items that they will be putting. So do some kind of reading of these kind of material. The sources are important. Now in this electronic age, a lot of information is available, lot of nice things are available, but a lot of not that nice things are also available. So one has to filter, and it's very difficult because the huge amount of content is there, varieties. So one should go for the reputed institutions. Like I choose this Scientific American. So every day they will say that this research is being done here and that is being done there, and so on. So American APS, American Physical Society. These kind of reputed institutions, research institutions, the citizens can just go and read and don't understand anything of it. No problem. It is at research level. It is at research level. But even they are trying to make it at citizen level so that people do understand, but not citizen level, but a botany person can understand chemistry, a chemistry person can understand atmospheric science, atmospheric science person can understand the solar radiation, like that. So some background is there. So if we do this kind of, NASA is doing wonderful these kind of stories. ISRO is doing wonderful stories. So those things, if I just read, I have a habit of reading all those things, then that connection will be there.
Or come to such talks.
Yeah, come to such talks.